All right, welcome back, everybody. I hope you're doing well and you're safe and healthy, and your families are safe and healthy. This will be the next video in our distant learning series. Today, we're going to be talking about solving rational equations. So the last week or so, we've been working on operations with rational expressions, add, subtract, multiply, divide. Today, we're going to kind of ramp it up a little bit and talk about solving rational equations. So I'm going to jump right in here. There's not a whole lot of background we have to talk about. I'm just going to give you a whole bunch of examples. Now, when I say a lot, I'm going to do about 7 different problems, but I'm going to give you an opportunity to pause the video a couple times to do one on your own. So if you don't have a piece of paper and something to write with, you might want to stop and get that while we're going through these things. So there's really 2 methods that we're going to talk about doing this. The first one, just like you've been doing since like middle school, we're going to solve some of these things just by doing some cross multiply. Okay, and that's when you're going to have one rational expression on each side of the equation, kind of like this example here. So you guys know how to cross multiply already. We don't need to talk about that whole lot. There's some different names floating around out there. But basically, we just cross multiply exactly what it says, right? So we're going to take the 3 times 4x plus 5 and set that equal to 9 times x plus 1. And then we're just going to do some algebra. So we need to distribute on both sides and then just continue solving for x, right? So if I subtract the 9x from both sides and subtract the 15, kind of get like terms together, you've been doing that for a while now, you get 3x equals -6. And then, of course, divide by 3, so x equals -2. Okay, and that's our solution, and that's kind of all we got to do. Now, there is something important, and you've been hearing this from your algebra teachers since you've been taking algebra, really, is whenever you get a solution, you should go back in and plug that number in to make sure it works. Same with these things here, guys. It's really important that, that you check your answers, because sometimes we're going to get these things called extraneous solutions. We'll talk about that in a few minutes, kind of when that happens. But the upshot is you should really check your answers. So in this case, if I plug in -2 to all the x's back in my original equation, and then just simplify things, notice that just becomes -3 on one side, -3 on the other side. So that means -2 is a solution, because you get the same thing on both sides of the equation. Now, I'm also going to show you, I'm not going to do this for every single one, but I'm also going to show you what this looks like graphically. And on Desmos, I kind of worked a little bit ahead, and I got some different problems already in here. And notice, these are my 2 equations, right? So I got 3 in the x over x plus 1, and then I have 9 over 4x plus 5. And notice the one intersection point they have, the one point they have in common, is this point -2, -3. So all I care about is the x value. So that's why the solution on that one was -2 and just x equals -2. Okay? So I'm going to get rid of those guys and then kind of get ready for that next one there. So that's what's going on when you're doing the cross multiplying thing. So let's go and do one more. And if you want to pause the video, even though you've already done one, if you want to pause the video and try to work through this on your own, I encourage you to do that. But I'm going to kind of keep on moving through this one. But again, we got one expression on both sides, so we're going to cross multiply. And then just write it all out. So x times x plus 11, 3x times 2x minus 3. Distribute just like before. Notice, don't forget your exponent rule. So we got some x squareds in there also. And the thing to remember too here, folks, is if you see an x squared, it's probably a good idea to get everything on one side, because that's kind of a dead giveaway that you're probably going to end up having to factor at the end. Okay, so in this case, I'm going to gather everything on the right-hand side. So I'm going to subtract x squared. I'm going to subtract 11x. And that's going to give me 0 equals 5x squared minus 20x. And of course, here, just like I said, we're going to have to factor that. But this is just a GCF. So notice our GCF is 5x. If I pull a 5x out, that means I got the x minus 4 left over. And we know how to solve that. We set each piece equal to 0. So 5x equals 0. That means x equals 0. And then we have x equals 4. as the second solution. So this one actually has two solutions, or at least it looks like it does. Again, we should always go back and check these answers. So if I plug both of those in, I kind of did it both at one time up here. So I've got, if I plug in 0 for all the x's, then it just becomes 0. And if I plug in 4 for all the x's, then both sides become simplified out to 4 over 5. Okay, so I'm going to show you this one on Desmos also, just so you can see what two solutions look like. In this case, I've got those here and here. And if I just highlight one of those graphs, you see there's the point 0, 0. And then here's the point x equals 4. And again, we don't really care about the y value. It's just the x values that we care about. So those are the two solutions in this case. Okay, so that's really all that's going on these things, guys. So I've got one more of these guys. So I am going to ask, even if you didn't on this one, I am going to ask you to pause the video here and try to do this in on your own. And I'll give you about 5 seconds, and then we'll go through the solutions just like we have on the other. Okay, so nothing different. Cross multiply, distribute on the left, FOIL or box method, whatever you're more comfortable with on the right. But again, notice I've got the x squared term, so I'm going to get everything on one side, subtract the x squared, add the positive x, get everything on the right hand side, and now it's going to become x squared minus 2x minus 35. And alarm bells and sirens should be going off in your head right now. You're like, oh yeah, I know how to factor that. So when we factor that, that comes out to be x minus 7 times x plus 5. And of course, when we solve both of those things, x equals positive 7, x equals to negative 5. Okay? And just like I've been saying already, we need to make sure that they both work. You plug in 7, you plug in negative 5, and both of them, if you do that on each of them, you'll see that they come out to be the same thing on the left and right, and that means it is a solution. I'm not going to do the graphical solution here just because I kind of want to move on to the next example and not keep you here all day long. Okay? Again, if you didn't get this one right, or anytime you need to pause and kind of go back and look at the examples again, same thing as you're working on the assignment later on, feel free to bring this video back up and kind of go back and make sure you understand the process of what's happening. Okay? So I got one more of these that I want to show you because something interesting happens on this. So we're not doing anything different. We're still cross multiplying, and we're still distributing in the FOIL, all that good stuff like that, and we're still getting everything on one side. Notice I am going to get, just because I tend to be kind of lazy, I'm going to get everything on the left-hand side here so I can have my positive x squared. So it becomes positive 5x squared plus 19x minus 4 if you gather all those terms together. If you factor that, and you guys should remember how to factor something with a leading coefficient. This is, some people call it the AC method or the swing method. There's different names of it out there. But when you factor it, it comes out to be 5x minus 1 times x plus 4. So that would seem to mean that this factor here, this first one would mean x equals 1/5. You got to solve that. And then x equals negative 4. Well, okay, that's fine. So you think, oh, I'm not going to check these because they've been working so far. But look what happens if you plug in negative 4. If you plug in negative 4 to all that stuff, and I'll kind of leave the actual mathematics of it to you, but I plugged everything in here. Notice on the left-hand side, you get 2 over 0, and on the right-hand side, you get 17 over 0. Well, that's not the same thing. And we're not allowed to divide by 0. That's undefined. So that's really not a solution. Okay. Also, if you notice, if you look back at the original problem right here, we can't use negative 4 anyway. It's not in the domain of the original equation. So whenever that happens, whenever a solution doesn't work, we call that extraneous. Okay. So the only solution we have for this is 1/5. Now, in full disclosure, I didn't plug in 1/5 to show you that it works I promise that it does, but I will show you the graphical solution in this case. So you can see that even though mathematically we got two solutions, we really only have one solution to this. So here is this last one that I'll show you here. And you see right here, this is our one solution, and you see, I'll highlight that, so you see 0.2, also known as 1/5. That's our one solution, and you see here, -4, they're not going to intersect. There's an asymptote here, so there's no solution. The only one solution that we have is right here at that one point, okay? So again, will it happen all the time? No, but it will happen sometimes. That's why it's really important that you want to plug in your solutions so that you can see, make sure either both of them work or one of them doesn't work. There could be a situation where neither of them work and they actually have no solutions at all. So make sure you're plugging in those guys in, okay? Now the second method we talk about is something like this. So notice here, I've actually got a sum of rational expressions on the left-hand side. Now there are a couple ways you can do this. Some other teachers might show you a different way. You can actually combine those fractions on the left-hand side and you get one fraction and then cross-multiply. I'm going to show you a different method. One that once you kind of get the hang of, it makes life quite a bit easier. So the method I'm going to talk about here is look at all the fractions. We're not even combining anything. Just look at every one. So I got 5/x, 7/4, and -9/x. And you ask yourself, okay, what would the common denominator be of all of them? And then kind of put that in your head real fast. And then what we're going to do, we're going to multiply the whole equation by that common denominator. And then solve it out from there, okay? So what is that going to look like? In this case, my common denominator, notice I've got an x, and I've got a 4, and I've got an x. So my common denominator can just be 4x. So if I multiply the entire equation by 4x/1, watch what happens. So by distributing that 4x through, I've got 20x/x, I got 28x/4, and I got -36x/x. Well, if I clean that up, that just becomes 20, because the x's cancel. This just becomes 7x, because 28/4 is 7. And this just becomes -36, because again, the x's cancel out. Now there's not a single person watching this video that can't solve that equation for x. Okay, so if you add 36 to both sides, you got 7x. I'm sorry, subtract 20 from both sides. I apologize. Subtract 20 from both sides, you got 7x equals -56. Divide by 7, you have x equals 8. And that's it. And again, in the interest of time, so I don't keep you here all day long, you should check that answer. I promise it's right, but you should still check that answer by plugging that into the original one. Okay? So that's it. So you find your common denominator of all the fractions, you multiply through that, watch your math and your distributing. It'll simplify out to something very straightforward to solve, and then you kind of go from there. Okay, and this will check the answer. Let's do one more of those. So we've got 3/m² equals m-9/3m² plus 2m. Again, you think to yourself, what's your common denominator? And in this case, it's going to be 3m², because again, you're looking for that least common, the thing they would all have in common in the best case scenario, right? So if I multiply everything by 3m² and then distribute, I get this, and I'll let you kind of read through that on your own. And notice what happens if I simplify. It becomes 9 equals, the 3m² cancel out, you leave with m-9, and then one of the m's cancel out here, which would be 6m. And again, I can just simplify, I can just solve that right off the bat. So m plus m on the right-hand side here becomes 7m. I can add 9 to both sides, divide by 7, So m is equal to 18 over 7. And again, this answer ends up being a weird fraction. Who cares? Because we're done. This would be a little bit of a struggle to plug it in. But again, I promise that it does work, and that's an exercise that you should do along the way. Okay? All right, last example, and again, I'm going to have you pause the video one more time and see if you can do this one by yourself, kind of using that same method we're talking about by multiplying through my common denominator. And so I'll start going through the solution here in about 5 seconds or so. Okay, so in this case, what have you come up with for your common denominator? Well, it's just going to be the product of those two things. And it doesn't matter that I have 2x minus 1. We can just count that as the same denominator, right? So I can just multiply by x minus 1 times x plus 2. Distribute that all through here. Now, just because I didn't have a whole lot of space, kind of prepared yourself for this next one here. When I multiply this whole thing times this, notice the x minus 1 will cancel. Just leaving me with the 4 times x plus 2. And then for the second one, when I multiply this whole thing by the second fraction, the x plus 2's cancel. So it's 6 times x minus 1. And the same thing when you multiply that last one, you have the x plus 2 left over. Okay, now we need to distribute. So 4x plus 8, negative 6 plus 6, watch that sign, equals x plus 2. Gather everything on one side. Negative 2x plus 14 equals x plus 2. Keep on solving for x. We got negative 3x equals negative 12, and x equals 4. And that'll be your final answer. Okay, so again, I know we went through a bunch of examples here, so there is going to be an assignment posted on Classroom on the same kind of solving questions that'll kind of give you an opportunity to look into reviewing some factoring things, and I'll have some from both methods, both just straight cross multiplying, and then this method here where you kind of multiply by a common denominator. Okay, so remember, we have those two different situations there. If you just have one rational expression per side, cross multiply, you might have to factor there at the end if you have an x squared term in there. Make sure in check solutions, you might get an extraneous solution. If so, then that's not a real solution. You just kind of cross that out, just do the other one. If there's more than one rational expression on one of the sides, that's where you can find a common denominator, multiply by that whole equation, simplify it just like we did in those last examples, and then check solutions. Okay? I will put a link to Desmos. That's how I made those graphs. You can certainly check your work when you're doing your assignment. You do need to show your steps. So, just doing the graphical solution and writing the answer is not going to be sufficient. But you can certainly check your work and make sure that what you do by hand is supported graphically. Okay? Feel free to share this with anybody else going through solving equations right now. Feel free to subscribe to the channel for some more distance learning content as we kind of go through all this stuff. If you have any questions, you can message me or drop me an email, or I'm sure if you don't have me as your teacher, you can email your teacher and they'll be happy to help you as well. Okay? Thanks again for tuning in. Hope you found this helpful and informative. Everyone stay healthy, stay safe, and we'll see you next time. Keep studying.